In previous videos, we talked about how having an omitted variable in our multiple linear regression can cause bias and inconsistency in our OLS estimators. Now, in this video, we're going to show how we can use proxy variables to partially resolve or at least mitigate some of this omitted variable bias. You could encounter situations where you have a model and it excludes a key or a significant variable because maybe data is unavailable, right? So maybe there's data unavailability and that causes omitted variable bias. In those instances, we make use of what we call proxy variables, but there are certain guidelines before that you want to keep in mind before you implement using proxy variables. So one thing that we've talked about is that the source of bias in OLS is are omitted variables, and this occurs because the explanatory variables are correlated with the error term. Okay, so when this occurs, this causes the bias or inconsistency in our OLS estimators. So we can basically use proxy variables to mitigate this problem. Now, we're going to get into causality perhaps in the next semester, and in part 3 of the book, we deal with how to estimate causal effects, but here we're going to try to understand it more intuitively of how that works. So an example here is something you're familiar with again. We're looking at regressing log wage on education experience, and what we're really interested in are these returns to education or returns to experience here. Okay, but we might believe that maybe ability plays a role in wage determination. So since we know that by definition ability is something that we can't measure very easily, we're going to have some sort of data problems because the data on ability is unavailable. Okay, so in this case, we're going to try to see how we can employ proxy variables, proxies for ability, to estimate beta 1 and beta 2 correctly. So here, one thing to keep in mind is that assume that with ability included in the regression, all those 4 assumptions that we keep talking about in multiple linear regression hold. And so the OLS estimates that you get for beta 1 and beta 2 are unbiased and consistent. So now we've already said that ability is unobserved. Okay, so if we omit ability from our regression, then the coefficients on education and experience are going to be biased and inconsistent. In other words, our OLS estimation would suffer from omitted variable bias, and we want to mitigate that problem. So what we can do is introduce something that might be maybe an imperfect proxy, but still a proxy for ability. So something like IQ scores. Maybe we have data on this, and we can introduce something that affects. I don't believe in that, but yeah, well, sure. We can use some data to see if there is some kind of relationship there that can be, or some sort of bias that can be eliminated by introducing IQ scores. Okay, so the only advantage that IQ score gives us is that it is actually a measured variable and we actually have data on that. Okay, and that can serve as a proxy. So let's try to understand how we generally think of an unobserved variable in our multiple linear regression. So here, this is a pretty standard regression, but you note here that there's an asterisk on x3. So x3 star, the star is basically indicating that this is something that is unobserved. Okay, and in this case, we're basically saying our x3 star is ability. Okay, so what we really want to do is we want to control for ability to get unbiased and consistent estimators for beta 1 and beta 2. So in other words, we are trying to estimate the ceteris paribus effects that x1 and x2 have on y, which is wages, holding ability fixed. Okay. Now we can't estimate beta 3, right? That's a given. We cannot estimate beta 3 because we don't have data on x3 star. Okay, so let's move on and think about a proxy variable x3. So here, notice there is no star. I'm denoting x3 as the proxy variable. Okay, and we'll see if we can introduce that in our regression to get some unbiased and consistent estimators for beta 1 and beta 2. Now, the variable x3 that we can observe should be some sort of a linear function of x3 star. So, I'm sorry, the x3 star should be a linear function of x3. So this is unobserved. Let's say this is ability, and this is observed, which is something like IQ. So there is some sort of a linear relationship between ability and IQ, and we basically incorporate the fact that x3 star is not perfectly related to x3, right? So the correlation between x3 star and x3 need not be perfect. Well, we can't really compute correlation, but basically there is no perfect relationship. And so this is the part of theory that we are doing here. So this is, more like a theoretical concept. In theory, there's some sort of relationship, but it's not perfect. Now, another thing to keep in mind is that we want that the correlation between x3, which is our observed variable like IQ, and our error is equal to 0. And that it is only that the unobserved variable has a direct effect on y and not the unobserved and not the observed. So basically we're saying that if we are trying to determine wages, ability has a direct effect on wages, but not IQ, okay? IQ is going to affect wages, but it is going to go affect ability first and then affect wages. So there's some sort of an indirect channel here, okay? And I think the chapter on instrumental variables next semester will deal more with this idea. The second requirement, so this is the first requirement, the second requirement of a proxy variable is more difficult to achieve. So we basically say that the conditional mean of x3 star, when we condition it on all these x's, including the proxy, should just be equal to the conditional mean of x3 star given x3, given the proxy, okay? So we'll try to understand that, using an example. But basically what we're saying is that this relationship should hold, right? If you added x1 and x2 in this regression, x3 star should not be related to that, okay? So we're assuming here that the covariance or correlation between x1 and v3, which is the error here, is 0. and the correlation between x2 and v3 is also 0. Okay, so what this translates into is that x3 is such a good proxy for x3 star that once we know x3, neither x1 or x2 would help predict x3 star. So in other words, education and experience in our regression should not predict ability. What should predict ability is just IQ, okay? So conditional on IQ, education and experience are not partially correlated with ability. So what we can do is write out that equation again and make two assumptions about IQ, which is our proxy variable, right? So instead of ability, we want to include IQ. So the first thing we want is that IQ does not need to be in the equation as long as ability is in it, right? So if you know ability, if you can measure ability, you have data on it, you don't need a proxy, right? And the second thing is we're only going to incorporate IQ, which is a good proxy for ability, when we can assert that delta 1 and delta 2 are 0. That means education and experience do not affect ability. So if these conditions are satisfied, typically we can use x3 as a proxy for x3 star, or we can use IQ as a proxy for ability and use it to estimate beta 1 and beta 2. So let's see how we can do that. So we've established now that we are thinking about this sort of imperfect relationship between x3 star and x3. So the unobserved and the proxy variable. So all we're going to do is we're going to start with that same regression where this was x3 star is the unobserved. And we're going to substitute in this on the right hand side instead of x3 star. So once you plug that in and you solve for it, you're going to get an expression which is going to be slightly different, okay, where your intercept is different than before and your error is different than before, and the coefficient on x3 is different, okay? So something that you want to keep in mind here is that you can still estimate. Notice that our beta 1 and beta 2 are not getting influenced. Those are attached to x1 and x2 just like before. So we are able to estimate those coefficients in an unbiased and consistent way by using a proxy. Okay, so remember that when using proxies, we can't estimate what we started with. We can't estimate beta 0 or beta 3. Can estimate these two, but if we are interested in, let's say, returns to education or the effect that experience has on wages, then we can do that by using proxies, because we're not really interested in beta 3. If you're interested in beta 1 and beta 2, we want those to be unbiased and consistent.